Hey guys, so this video is going to talk about the periodic table square, the square that you see when you look at the periodic table with the element symbol in it, and we're going to talk about the parts that you see and what they all mean and what information they can tell you. So first, the most obvious one we have in the middle, always the element symbol. Element symbol is the abbreviation of the name. It's how we write the name instead of writing it all out because scientists are lazy, basically. So we have the element symbol. The other piece of information that's really obvious, especially when you look at the periodic table that's in our classroom, is the blue number at the top. And this number, I'm sure you've heard of it before, is called the atomic number. And this number is very, very important because it is the identifier. It tells you how many protons are in the nucleus of the atom, of a single atom. How many protons? And like I said a second ago, it's the identifier. If I said that an element has 54 protons, what element is it? The answer is xenon, and the answer is always xenon, and that answer will never, ever, 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 ever change. The number of protons is used to identify. The number of protons never, ever, ever, ever changes. And if it did, let's say we somehow used science and we took a proton out of xenon and then it had 53 protons. Well, it's not xenon anymore, it's iodine. It is the identifier. This number tells me what it is. If it's 53, it's iodine. If it's 54, it's xenon, et cetera, et cetera. So the atomic number doesn't change. It tells you how many protons, and that's that. Okay, moving on. So down here at the bottom, we have this number, and you'll always notice it's a decimal for the most part. I need a skinny red here. Okay, so this number is called the atomic mass. And it's easy to mistake this number for something else called the mass number. So the atomic mass, we're just going to define it here, and then I'll kind of explain what it means. So the atomic mass is the average. Oh, this pen is super thick. Hang on, let me get a skinnier one. Okay, so the average mass for all known isotopes. Okay, so there's a couple new words here. So it says atomic mass is the average mass. The average mass number. Hang on, I'm gonna average mass number for all known isotopes of an element. Okay, so there's a couple pieces here, so I'm just going to scroll over so I have some room. The first piece that we see is this mass number, and I said that you guys think you know what atomic mass is, but really I'd bet you're thinking of mass number. So the mass number is the number of protons plus the number of neutrons. So protons plus neutrons equals the mass number, and therefore protons minus the mass number equals the neutrons. The mass number is always a whole number because we can't have half of a proton or half of a neutron, right? WHOLE, whole number. I think that's it for that. So mass number, protons plus neutrons, always a whole number. So then it goes on here, it says for all known isotopes of an element. So isotopes means something is different from one atom to another. And remember, if the mass number is protons plus neutrons, and the protons cannot change ever, ever, never, ever, we cannot change the number of protons, otherwise we change the identity, we change who it is. Therefore, the number of neutrons must differ in this thing here called an isotope. So an isotope now, let's come over here. An isotope is an atom of an element with a different number of neutrons. And this is important because this is where we get that decimal from in the atomic mass. So let's say, for example, okay, I know, carbon. So we have carbon, and carbon is atomic number 6, right? And its mass number, or its atomic mass is 12.01, blah, blah, blah. So we also, I'm sure in your life, have heard of carbon-13, right? Carbon-13. Well, we know that carbon's atomic number has to be 6. So carbon-13 means that it had 1 extra neutron. Therefore, its mass number, instead of being 12, would be 13. Because we had, again, so 13 minus 6, so that's the mass number, minus the atomic number is going to give me the number of neutrons, which in this case would be 7. So we have different isotopes of an element, meaning we have different number of neutrons, and the different number of neutrons affects the mass. So when we say carbon-13, carbon-12, carbon-14, those are all the isotopes of carbon. Now, carbon-12, if we round this 12 down here to the nearest whole number, that's the most common isotope. And so like anywhere, that you go look and you see carbon, it's usually carbon-12. Isotopes are typically unstable. They're radioactive. They have like a short life. You can calculate their half-life and things like that. And that's why they're used. That's why carbon-13 is used for dating and whatnot. But that's basically this number here, this atomic mass, is just the average of all the isotopes. And that's why you see that decimal in there. So mass number is the whole number. Atomic mass is the average of all the isotopes in their, abundance in terms of like what percentage of the carbon on Earth is carbon-12 versus carbon-13, et cetera, et cetera. So there you have the periodic table square. There is some things missing here. For example, if my atom has a charge, there's no way to know that by looking at the periodic table square. And I don't know the mass number of my atom by looking at the periodic table square. I just have the atomic mass. So we have something called the isotopic symbol, which I am going to show you in the next video.